Dear colleagues, we offer you a report on geometric interpretation and visualization of particular geometric concepts at a metric spaces study. The work considers the issues of studying methods of geometric properties of metric spaces in higher school. First, we present some basic concepts related to metric spaces. Such concepts are the distance between the points of space, definition 1, the rectilinear arrangement of points in space, definition 2, the rectilinear set of points in space, definition 3. In the following, we will consider several classical spaces. The metrization is based on simple concepts and which are easy to illustrate even on the material of the school course of mathematics. Formula 1. This space is Rn. Formula 2. This space is CAB. Formula 3. The space is CL. The authors also use the concept of angle in metric spaces, definition 4, and its numerical characteristics, definition 5. With the help of these concepts, it is possible to establish the notion of a flat arrangement of points in a metric space, definition 6, and a flat arrangement of a set of points in a metric space, definition 7. Visualize the mutual location of the 4 points A, B, C, S of the metric space, the distances between which are known. We construct a corresponding tetrahedron ABCS in dynamic geometric environment GeoGebra 3D. Place of vertices are in the center of the system of three-dimensional Cartesian rectangular coordinates space R3, and the vertex B on the positive half axis of the abscissa. When calculating the coordinates of the vertex of the tetrahedron of the ordinate of the point C and the application of the points S, we will always choose non-negative ones. Thus, the oriental tetrahedron is presented on this slide. Since in GeoGebra 3D it is possible to construct a tetrahedron only on the coordinates of its vertices, the authors used the formulas for calculating the coordinates. These formulas are present in this slide. Consider an example 1 of visualization of the mutual location of the 4 points of space C01 in GeoGebra 3D. These are linear functions. In space C01, all distance between points will be equal to 1. In space R3, these points will form a regular tetrahedron. In GeoGebra 3D, the corresponding tetrahedron is shown in this slide. This image can be rotated so that the point of view lies in the plane of the X or Y in this slide. Going to space CL, we change the relative position of these points. The distances between the points will change. The interpretation of this arrangement of points is presented in this slide. Consider example 2. These are linear functions. Having found the distances between these functions in the space C01, we can make the following interpretation of their mutual position in the space R2. Having found the distances between these functions in the space C01, we can make the following interpretation of their mutual position in the space R2 in this slide. Conclusions. The examples of geometric interpretation and visualization of the mutual points placing of metric space given in this paper can contribute to a deeper and more conscious perception and understanding of the metric space theory. The analogy of particular connections between of the points of metric space with the corresponding connections in Euclidean geometry makes it possible to trace the change in the characteristics, geometric properties of space at its metric changes. The use of special graphical capabilities of the corresponding software allows not only to visualize and the mutual points of placing of the metric space, but also to track its change at changing observation point of placing. Thank you for your attention.